Welcome to EtherLink AI Insights, the podcast where we break down the cutting-edge developments shaping enterprise AI. I'm Alex, and I'm joined today by Sam. Today, we're diving into a topic that's reshaping how organizations build AI systems, multi-agent orchestration and building superagents, with a special focus on what's happening in Amsterdam's AI hub and beyond.
Thanks, Alex. And honestly, this is a conversation that needs to happen because there's been a massive misconception in the industry. For years, we've been chasing this idea of the ultimate autonomous agent, one AI system that can do everything. But that's not where the market is heading at all.
Right, so let's unpack that. What changed? Why did enterprises suddenly decide that maybe one super-intelligent agent isn't the answer?
Data shows it pretty clearly. According to recent enterprise surveys, 73% of organizations now prioritize reliability and error recovery over pure agent autonomy. When you're running mission-critical workflows in finance, healthcare, or logistics, you can't afford to let an AI system make autonomous decisions without oversight. The cost of failure is simply too high.
So instead of one all-powerful agent, you're building teams of agents. That's the shift we're seeing, right?
Exactly. And it's not just a shift in thinking, it's producing measurable results. IBM and FPT Intelligence predict that these team-based AI systems will boost productivity by 40 to 60% across enterprise sectors by 2027, compared to standalone agents that often get stuck at proof of concept. The math is compelling.
That's a huge difference. Walk us through what this actually looks like in practice. How would a company structure this?
Let's use a concrete example. A financial institution. You'd have one superagent, and this is important. A superagent is not an all-knowing AI. It's an intelligent orchestration layer. This superagent might receive a request like, analyze this market opportunity for investment. It doesn't do all the work itself.
So it delegates?
Precisely. It routes the request to a specialized market analysis agent, spins up a risk assessment agent, brings in a compliance agent to check regulatory requirements. The superagent then synthesizes all those results, identifies conflicts or inconsistencies, and presents a recommendation that human decision-makers can actually trust and approve. That's orchestration.
I see. So the superagent is more like a conductor than a performer. It's coordinating specialists. And you mentioned something really important there, human oversight. That's baked into the architecture, not bolted on after.
Bingo. And that's where the EU AI Act compliance angle becomes crucial. Regulators aren't interested in black box autonomous systems. They want to see clear decision trails, human judgment at critical junctures, and auditability. Multi-agent orchestration architectures are built for that from day one.
Let's talk about the underlying infrastructure. You mentioned control planes. What are those exactly?
Control planes are essentially the nervous system of multi-agent systems. They manage communication between agents, route tasks, resolve conflicts, and maintain audit trails. Without a solid control plane, you've got chaos. Agents stepping on each other, no visibility into what's happening, no way to ensure compliance.
What does a control plane actually do in technical terms?
It handles inter-agent messaging, task routing, and conflict resolution. It keeps audit logs so you can trace every decision. It monitors performance and costs in real time. And critically, it enforces guardrails, rules about what agents can and can't do. If an agent tries to exceed its authority or access resources it shouldn't, the control plane stops it.
So it's almost like a security and governance layer built into the system architecture.
Exactly. And the best control planes use what's called an agent mesh architecture. Instead of having one central hub that everything funnels through, which is a single point of failure, you distribute the orchestration logic. Agents can operate semi-independently while remaining fully observable.
What's the practical benefit of that distributed approach?
3 big ones. First, you eliminate single points of failure. If one component goes down, the system keeps running. Second, you can scale horizontally across distributed infrastructure without rebuilding your whole architecture. Third, you get complete audit trails for every interaction, which is non-negotiable for compliance. Research from Google's ML Ops team in 2025 showed that mesh architectures reduce system downtime by 67% compared to traditional hub-and-spoke models.
That's a significant reliability improvement. But I imagine evaluation and testing these systems is complex. How do you know if your multi-agent system is actually working?
That's where evaluation frameworks come in. You need continuous, rigorous testing, not just of individual agents, but of the orchestration layer itself. Are agents communicating effectively? Are decisions being made correctly? Are guardrails being enforced? Are audit trails being maintained?
So it's not enough to test each agent in isolation.
Not even close. You need integration testing, stress testing, adversarial testing. You want to see what happens when agents disagree, when data sources conflict, when edge cases emerge. You need to validate that your control plane actually maintains compliance under pressure. This is production-grade engineering, not academic experiments.
And I imagine that complexity is why Amsterdam and other AI hubs have become such important innovation centers for this work.
Absolutely. Amsterdam's tech ecosystem has a combination of things you need: strong technical talent, forward-thinking enterprises willing to experiment, regulatory clarity around the EU AI Act, and a collaborative culture. Enterprises and vendors are literally solving these orchestration challenges together in real time.
So if someone's listening to this and thinking, I need to implement multi-agent orchestration at my organization, what should they be thinking about right now?
Start by identifying your use case clearly. What problem are you actually solving? Is it something that genuinely requires multiple specialized agents? Then think about your control plane architecture early. Don't treat it as an afterthought. Build compliance and auditability into your design from the start, not as a retrofit.
Any other critical considerations?
Invest in evaluation frameworks before you deploy to production. Know how you're going to test multi-agent behavior. Think about your observability. You need real-time visibility into what's happening. And be realistic about the governance overhead. These systems require more human oversight than standalone agents, and that's a feature, not a bug.
So the message is, multi-agent orchestration is becoming the standard for enterprise AI. It's more reliable than autonomous agents, and it's built for compliance from the ground up.
That's exactly right, and the organizations implementing this well right now are going to have a massive competitive advantage when we hit 2027, and this is just table stakes across industries.
Sam, thanks for breaking this down. For our listeners who want to dive deeper into control planes, super agent architecture, and production deployment strategies, head over to etherlink AI and find the full article. It's packed with technical insights and real-world examples. Thanks for listening to EtherLink AI Insights. I'm Alex, and we'll catch you next time.